This is the summary created from the video. Lecture 27, Multithreading-I. Multithreaded programming is a powerful technique that allows efficient utilization of multi-core CPUs by running tasks concurrently, with each thread handling different parts of the program simultaneously. Unlike single-threaded execution where statements run sequentially, multi-threaded programs can execute code in parallel, with threads sharing the same memory space for efficient communication and data exchange. Multithreading is crucial for developing complex software as it enables parallel execution of tasks like sorting, calculating, and searching, improving application responsiveness and overall performance. While multitasking allows running multiple programs concurrently via CPU time slots, multithreading takes a different approach by executing multiple threads within a single process. Multiprocessing involves executing multiple processes concurrently on different processors, with modules assigned to separate processors for parallel execution, resulting in faster program completion compared to single-threaded approaches. A process is an executable program loaded into memory and managed by the operating system, while threads represent sequential execution of instructions within a process, allowing multiple threads to execute concurrently and share data. Multithreaded programming finds applications in various domains, such as web servers processing requests from billions of users simultaneously, email servers handling concurrent user loads, and internet servers processing client requests in parallel. In Java, multithreading is facilitated through the class and runnable interface, providing methods like start, run, join, sleep, and yield for thread control and synchronization. Creating threads in Java involves defining a class that extends the thread class and overriding the run method with code to be executed by the thread, or implementing the runnable interface and creating thread objects from the thread class. Understanding thread creation, scheduling, communication, and synchronization is crucial in multithreaded programming, as it enables improved application responsiveness, performance, and efficient utilization of system resources through parallel task execution. Please stay tuned for more summary videos.